Hello and welcome at ESAB Digital Solutions. Today's video is about the basic functions of the WeldQAS checking program creation software for continuous tube and pipe welding. The objective is to provide an overview of the entire range of functions of this part of the program in order to apply this knowledge practically in the next video. Teaching perfect limits is the heart of HKS monitoring strategy. If the limits are learned incorrectly, this can lead to increased scrap of good parts or the defective seams are not even detected, which can lead to expensive recalls. That is why it is necessary to master this program properly. To open the checking programs in the WeldQAS software, you can use the button or the function key F3. This can also be done during monitoring. The main menu of the checking program setup can be seen now. In the middle you can see all the checking programs that have been taught in so far. These are numbered clearly from 1 to 999. The symbols behind the program name indicate which channels are recorded, and the symbols with a yellow background are all monitored channels. The table can be adjusted by dragging the headers in the preferred order and size of each individual column. The green dot in front of the test program indicates that this program is currently active. And the program on top, the so-called master program, is a placeholder which cannot be deleted. In the bottom configuration line, you will see various buttons. You can use them to open or edit checking programs, as well as create new checking programs or copy existing ones. In the menu button, individual checking programs can be permanently deleted or the checking program can be exported and imported again. This is useful for saving the test programs or if the checking programs are to be edited on a different PC. The last interesting setting on the main screen is the configuration. Here the paths are set from which folder the checking program creation software stores or loads the data of the checking programs, or with which results database the checking programs are to be taught. On the HKS WeldQAS devices all settings are already pre-configured so that no adjustment is necessary. If the software is installed on a PC, however, the data paths must be set. The last button you will see is the close button. Now we open a checking program and have a look at the working interface. To do this, we select one and go to edit or double-click on the program. When the program is opened, you will immediately notice the curves. These are the last curves that can be found, which were recorded with this specific checking program. On the right, you can select from which parameter the curve should be displayed. If these are highlighted in yellow, they are monitored, gray channels are recorded and white channels are not recorded, which I will discuss later. Now we go back to the curves. The curves can be zoomed in from left to right or zoomed out from right to left as in any other diagram in the WeldQAS software. With a click on the right mouse button, functions such as displaying the measuring points or dynamic scaling of the y-axis will appear. Below the curves you will see various tabs, which I will discuss in more detail now. The first tab are the basic values. In the basic values, the name of the checking program can be entered first and you can fill in several other information about the component or welding process. At the next tab, all channels that the measuring system can record are displayed. Furthermore, the measuring and the monitoring can be activated or deactivated here. The measuring means that the system records and these channels and stores them in the database. If measuring is activated, the channel is no longer highlighted in white. Monitoring means that this channel is monitored with limits and error signals are generated when these limits are violated. You can see that a channel is being monitored by the yellow highlighted backgrounds on the right side. The tab specific values is used to adjust the limits. The WeldQAS system is a comparing system. To set it up, good reference weldings must be recorded before. The limits are then adjusted to the existing tolerance band of the recorded reference welds. When a flaw occurs, it deviates from the reference and exceeds the limits. The system has 4 different limits per monitored channel which must be set individually. These are the upper and lower warning limits, which are colored yellow. and the upper and lower error limits, shown here in red. For example, the two yellow warning limits can be programmed. If they are exceeded, no error signal is given out. Only when the red error limits are exceeded, an error signal is activated. The values, which can be entered here, are either absolute values or values in percent. This can be decided with a click here. The starting point for setting the limit values is always the nominal value, which is also defined as 100%. This is calculated from the selected data sets. Besides the limits, some other features can be set here. The first one is the pre and post trigger. This is used to extend the recording time at the beginning or end of the weld scene. Because the pipe production is a continuous recording, no settings have to be made here, and it should always be set to 0. It is quite similar with the setting for the start and stop time of the monitoring. Here labeled as start and stop mode. With this setting, areas can be excluded from the monitoring, which is not necessary for continuous pipe production. So also, this value should always be 0. The time tolerance is a setting that can only be made when monitoring with envelope curves takes place. In this case, however, there are fixed horizontal limits for which this setting has also no relevance. Another parameter on this desktop is the sensitivity. To explain this, let's briefly switch to a graphic. The sensitivity is used to evaluate short peaks that exceed the limits but that shouldn't be marked as bad. The way it works is as follows. If a parameter curve exceeds the limit shorter than the adjusted time in seconds, it is still evaluated as good. If the parameter violates the limit longer, it will be evaluated as bad. The last setting that can be made in this tab is the setting if this parameter applies to all monitored measuring channels or only to this one channel. In case of the last one, do not forget to set these parameters for other channels as well. Let's move on to the next tab. This is the so-called simulation and a very powerful tool. First of all, it is used for data selection. By entering a certain number of record and pressing the filter button, you can load the number of the latest welds that were welded with this checking program, and that are stored in the database. By clicking in the time field, data can also be loaded from a specific point in time. A suspicious data set, which does not correspond to the references, can be sorted out via the exclude button or the delete key on the keyboard. The second function of the simulation is to re-evaluate the data. This evaluation is not taken over into the result table, however. It is used here exclusively to optimize the checking programs. Let me show this quick. By learning new limit values, it is possible to check how much scrap the system would have sorted out with the selected recordings. By help of the error time, it is identifiable when the worst evaluation took place and on which channel. Before we move on to the last tab, I would like to briefly explain the lower calculation button. This button is used to automatically set the limits. If you click on this button, you can select either Calculate New or Calculate Add. Let's take a closer look at Calculate New. This button starts several operations. First, it sets the new limits for only this selected channel with the currently selected welding data. Furthermore, it recalculates the nominal value. If monitoring has just been switched on, this button must also be pressed once that the limits are generated at all. Since the limits cannot be calculated optimally for every channel in every process, it must be checked that the limits were set optimally for the process each time the limits are relearned automatically with the calculation button. If necessary, the limits must be adjusted. The Calculation Add button eliminates single limit violations. It sets only the limits automatically again which were cut with the parameter curves. With this you have now the basic knowledge to teach in limits. Let's jump back to the last tab, the additional parameters. Here, the distance between the measuring line and the marker or the measuring line and the saw must be entered in millimeters for each checking program. If this is not done, the marking of the defect and a one-to-one correlation of the data records to the real cut tubes is not possible. If an already existing checking program was copied, the values are already entered. All other values are special settings, which are configured during commissioning by the ESAB staff, and these settings play no role for the majority of existing systems, so this should be 0. Up to now, the test program has only been edited. However, the evaluation with the new test program only takes place from the time when this test program is confirmed with the OK button. If no changes should be carried out, this program can be closed with the Cancel button. This was now the rough overview of the program part called Checking Programs Creation. For the procedure to create a new checking program, please watch part 2 of the video series.